All right, so in the last video, we quickly covered all of the key features of polynomials. Again, in this video, what I want to do is focus on key features of graphs, okay? Remember, domain is my x values, range are my y values, max is high spots, min is low spots, roots or zeros is x-intercepts, multiplicity is going to go along with the roots or zeros, and then in behavior, again, what y value does my graph go to at the ends, okay? Honestly, guys, the more I do these, I like to start with in behavior because I think it's the easiest. Again, label my left, label my right. Left, negative infinity, is pointing up towards positive infinity. Right is positive x, it's pointing up to positive infinity. So both of my going to y values are positive infinity. From here, I like to do max and min, okay? I'm going to start off with max, so I'm looking for high spots. It's like I see infinity. I see this point right here, and I also see this. The reason I did that point is because it keeps on going and going and going. So my max values are this, we could say like 1 and infinity. So the absolute ABS max is equal to positive infinity. If these did not have an arrow and it was dots, we would just label them accordingly. Mins, I'm looking for low spots. Okay. And I'm going to count down 1, 2, 3, 4, 5. And then -2. And my absolute min. Okay, so of these, which one is smaller, all right? Which one is lower? It's this -5, okay? And over here, the positive infinity was bigger, all right? Range is gonna be your absolute man and absolute max put together. So -5 to infinity. I don't have an open dot at -5, so remember, it's a bracket, infinity, always parentheses. Then I go to domain. Whoops. All right, so this graph has an arrow on the left, so from negative infinity, and then you just trace it until you see an open gap or a break in the graph, left to right. There is never no breaks, and I have arrow, arrow, so that means negative infinity to positive infinity. Roots are zeros. Again, where does the graph cross or hit the x-axis? At all of those purple dots. And -1, 2, 3, 4. -1, 1, and 3. Because all of these intersects and goes through, right, none of them bounce, we would just say the multiplicity of these are all odd. All right, number 5. Again, I'm going to do in behavior just because I think it's the easiest. Again, label my left, label my right. Right is positive infinity, left is negative infinity. It's pointing up to positive infinity. The one on the right is pointing down to negative infinity. And then we just write it accordingly. So as x goes to negative infinity, my left points up to positive infinity. My right points down to negative infinity. Again, then I like to do my maxes and mins. I'm going to try and keep consistent on my coloring. High spot, low spot, high spot. So maxes were, again, you're going to write these from smallest to biggest, 1, 2, 3. And remember, maxes and mins talk about y values. And of these, infinity is the biggest. So the one on the right. Next is going to be your low spots or your mins. So I color them. Negative infinity is the smallest one. Then -3. Again, you want the extreme. Okay. So I'm just going to say highlight are absolutes. Once you do your max and min, you then have your range. And you just piece together your min and max. Negative infinity to infinity. Infinity always gets parentheses. From, again, domain. It's got an arrow on the left, so it goes to negative infinity. And then you go from left to right, making sure there's no gaps or breaks or holes. There's not. So it goes all the way to infinity. Roots, zeros. Again, where your graph hits the x-axis. So I have a root or zero at -1, 1, and 3. Because they all go through and don't bounce. The multiplicity from these are all odd. And then last one. Again, left, right. So negative infinity is pointing down to negative infinity. Right, positive infinity points up to positive infinity. I have now my answer. I'm going to do my heels for my maxes. Again, write them smallest to biggest. So I'm going to say 0, 1, infinity. Highlight the biggest because it's the max, it's the most extreme. Next, I'm doing min, so my low spots. Again, smallest to biggest. -1, 2, 3. -1. Again, I want the extreme, so the smallest for the min. And again, my highlighted are the absolutes. And remember, range, you just piece together your absolutes. And you just do a quick takeover or a quick look over to make sure that you don't have any gaps, holes, or breaks in the graph, in which you would edit your range a little bit. Domain, because I have two arrows, it's negative infinity to positive infinity. Again, quick look over to make sure there's no holes, gaps, or breaks. There's not, so there's no domain restrictions. Roots are zeros. I'm going to have a root or zero here, 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 here. All right, so -1, 2, 3. 0, 1, and 2. -3, if you look at it, I know it's an even multiplicity because it bounces. 0, 1, 2 are odd because it goes through. And again, this -3 was even because it bounced. All right, so in the next video, what we're going to do is actually look at key features of equations.